Hello and welcome to today's session. My name is Dmitro Polishchuk, and this is our next DBT Talk expert session. And this time it's related to microbatch incremental models. For those of you who are new, I would like to say a couple of words about DBT Talk Hub and Speak. We make these sessions on first Thursday of every month, where we discuss various topics related to a transformation to DBT, as well as a DBT Cloud, and DBT package Data Vault for DBT, made and supported by scale-free developers. I do these sessions in turns with my colleague Ernan Rivale. If you would like to have a DBT session on some particular topic or functionality, you can send your questions upfront by filling out a form on our website, scalefree.com/dbttalk. So let's start. A few words about myself. My name is Dmitro Polishchuk. I'm a senior BI consultant at Scale-free. I've been working for Scale-free for more than 2.5 years. In general, I have experience in data warehousing and business intelligence since 2017, in particular in consulting and implementation of data warehouse BI solutions for different industries like retail, digital, finance, and others. From the educational side, I did a bachelor in finance and financial management. And then I also did some further certifications. The most relevant of them are CDV-P2, Certified Data Vault 2.0 Practitioner. I have a Microsoft certification related to data engineering on Microsoft Azure. I have Snow Pro Core certification. And the latest one is the certification related to the DBT Cloud administration. My core competencies in data warehousing are data engineering, Data Vault 2.0, Data Vault automation, and also dimensional modeling. So let's start with our topic. Microbatch is a new incremental strategy in DBT introduced in version 1.9 of DBT Core, and it's currently in beta. This strategy is specifically designed for large time series datasets and offers an efficient and straightforward approach to handling incremental transformations. It doesn't replace existing incremental strategies, but instead works alongside or complements them, providing additional options depending on the use case. One of the core features of microbatching is its reliance on a time column to define filtering ranges. This makes it ideal for datasets where time-based partitions are central or to how data is processed. Additionally, microbatching simplifies workflows by supporting the reprocessing of failed batches, something that can be challenging with traditional incremental strategies. Another advantage is its ability to automatically detect opportunities for parallel batch execution. That significantly speeds up processing times. By eliminating the need for complex conditional logic like that used in backfilling workflows, microbatching provides a more streamlined experience. However, it's not suitable for every use case. For instance, if your dataset doesn't have a reliable time column, or if you need more fine-grained control over the incremental logic, other strategies might be a better fit. How microbatches work? Microbatching works by splitting the processing of a model into multiple smaller queries or batches. These batches are defined based on two key settings: event time, which specifies the time column to use for filtering data, and batch size, which determines the size of each time period. This could be hourly, daily, and daily it's the default, monthly, or yearly. What makes a microbatching unique is that each batch is treated as an independent atomic unit. This means that batches can be processed separately, retried independently, or even replaced without impacting the rest of the data. This independence also allows for concurrent batch processing, where multiple batches are executed at the same time, improving efficiency and speed. The specific way microbatches are implemented depends on the adapter we are using. For example, on Postgres, DBT uses the merge strategy, which updates or inserts data. BigQuery and Spark rely on insert or write approach, and Databricks uses replace where to achieve the same goal. On Redshift and Snowflake, DBT uses the delete insert strategy, and we will look at this in our demo session with Snowflake. These adapter-specific mechanisms ensure that dbt uses the most efficient operation available for handling batch replacements. This flexibility and precision make microbatching a powerful tool for efficiently processing large time series datasets. You can refer to the dbt documentation to learn more about these adapter-specific strategies or mechanisms. Now let's talk about the key configurations for microbatch models. First, we have event time, which was mentioned before. It's the time column that defines when each event occurred. This column is crucial and needs to be set in UTC. Then there is batch size, which determines how data is grouped into batches. This setting was also mentioned before. You can set it to an hour, day, month, or even a year, depending on the granularity you need. Next is begin. This marks the starting point for processing batches, whether it's an initial build or a full refresh. This is also specified in UTC. There is also a look back, which is an optional setting. This allows you to include a specified number of previous batches to process prior to the latest, ensuring you don't miss any late arriving records. The default setting is for look back is 1. Finally, concurrent batches controls whether batches are run in parallel or sequentially. By default, dbt automatically decides this for you, but you can override it. Setting it to true enables parallel processing, while false forces sequential execution. Now let's talk about running batches in parallel, which can significantly improve the performance of your microbatch models. By default, dbt automatically detects whether batches can be executed in parallel. It evaluates the batch conditions and checks whether your adapter supports parallel processing. This automation means that in most cases, you won't need to configure anything manually. However, if you want to override the default behavior, you can use the concurrent batch configuration. Concurrent batches, sorry. This allows you to explicitly specify whether batches should run in parallel or sequentially. Currently, parallel execution is supported by adapters like Snowflake and Databricks, and there are plans to expand support to more adapters in the future. Now, there are a few conditions that need to be met for the parallel execution. First, the batch can't be the first or the last in the sequence. Next, your adapter must explicitly support running batches in parallel. And finally, your model logic must be independent or of the batch execution order. For example, if your model references this, which represents the current table being built, the batches will need to run sequentially to avoid conflicts. How to backload your data? When we talked about backloading eDBT, we're referring to reprocessing historical data. This is especially useful when you need to fix issues with data or apply updated business logic to past records. To backload data, you need to provide the event time start and event time end flags to your dbt command. These define the range of data that you want to process. It's important to know that both flags are required. You can't specify just one without the other. Once you define the range, dbt will process each batch within that range as an independent query as well. You can see the example of the command on this slide. dbt run, in this case, dbt run and 2 additional parameters specified. So in this case, it's 1st of February and event time end 3rd of February. This command will process all batches between 1st February and 3rd February respectively. And the range specified for the time end is not included. So this is important. We'll look at this during our demo session. And let's take a moment to compare the microbatch strategy to other incremental strategies available in dbt. First, unlike traditional strategies, microbatch templates independent queries for each time-based batch. This means it doesn't rely on a single old versus new comparison. Instead, every batch is treated as a standalone unit, making it easier to manage and scale. One of the standout differences is that microbatch does not require the isIncremental function in combination with this reference, which is very often used with the other incremental strategies. That means this strategy also reduces the need to the need for writing intricate SQL logic. Instead, it enables efficient parallel batch processing with much less manual intervention. For many users, this removes a layer of complexity from the SQL logic, especially when dealing with backfills or late arriving data. And finally, Microbatch automatically selects the most efficient operation for your platform. Depending on the adapter, dbt will use the best mechanism, whether that's insert, update, or replace, ensuring that performance and efficiency are optimized for your specific data warehouse. And now it's time for the demo on microbatching. I will stop sharing my screen for a moment. For this demo, I prepared a small dbt project that has two sources, customer and orders. Let's review them shortly in Snowflake. So table customer is a dimensional table. Attributes update often in this table, and some new customers are added, but all this happens not in a time-based manner. So the table contains approximately 150,000 records. So yeah, let's preview it shortly. So this is basically, yeah, as you can see, it's a simple dimension table. And the next table, the second table is table orders, and it is a time, or in this case, date-based table, namely fact table. New orders almost always arrive after already existing ones, and existing orders rarely update. So let's preview it as well. So this table contains about 1.4 million records. And the time-based column to be used by microbatching is order date, which is a date column with no time part. And let's review configurations in dbt. So the staging model customer is the first, and basically it's a simple select star from the table, so nothing of the importance. And the staging model orders is basically the same, select star from this model, but one very important setting is here is event time, which is set to our order date. And this setting will be used by the direct children configured for microbatch strategy. And we have only one child for this model, it's a fact orders. So this is our microbatch model. And the fact orders model joins and enriches data that comes from the model's customer and orders that we just reviewed before. And as you can see from the settings, it's configured as incremental microbatch model. Event time is set to order date, which is the date column in this model. Begin is set to 31st of January, which is 1 week ago. I set it for 1 week ago so that we don't have to wait for a long time when I run the full refresh. Remember that this setting is the starting point for an initial and the full refresh runs. Then the batch size setting is set for a day. And finally, look back. Look back is set for 3. This means that in addition to the batch for the current day, 6th of February, dbt will also generate batches for the 3 previous days when the model is triggered for an incremental run. And now let's look how it all works together. So I will delete, I already done that. I deleted the target folder so that we're able to see what dbt will generate for us. And now I will just simply run this dbt build command with full refresh option. And let's see. So as you can see from the logs, our staging models are refreshed as usual. But for our fact orders model, dbt generates multiple batches. And when we go to our target compiled order, time compiled folder, we will see that dbt generated 7 batches for the fact orders model. So starting from 31st of January, and all models, all batches contain exactly the same SQL. The only difference is that the order date is filtered using the respective time range for the current batch. And when we go to our run folder, so this here we can also see 7 queries. And if you look at the first one, the first batch, we see that here dbt uses create or replace statement for the first batch to actually create a table, and that for all the subsequent batches, dbt uses delete. Dbt executes delete just to delete the records representing the current time range being updated, and then right after that, dbt executes insert into statement to insert the new records. So all the subsequent queries look the same except for the first one. And so this is how dbt uses the delete insert mechanism for the batch replacement with Snowflake. Now I will delete the target folder again and execute the regular dbt run. Just dbt build. So let's go to our target folder again, and just a few more seconds. Okay, now let's go to our target folder again. And this time, the dbt generated 4 batches for the fact orders model. 1 batch is for the current day, so 6th of February, and 3 batches for the previous days, exactly as it is set in the lookup setting for our fact orders model. Remember that some batches may fail, and it was, as it was mentioned during the presentation, you can reprocess the failed batches with the command dbt retry. But for the lack of time, I won't cause any batches to fail in this demo. Instead, I will show you one more dbt command used when you need to reprocess some batches in the past in order to backfill the target table with later on records, for example, or to apply updated business logic to past records. Just let me copy this command. So as was mentioned during the presentation, you have to use 2 additional command line parameters. So it's event time start and event time end. Both flags are required together. I will just delete the target folder again before starting this command. So let's run this and see what dbt will generate for us. Okay, let's go to the target folder, target compile folder. And here you can see that dbt generated 2 batches, not 3. So for the 1st of February and 2nd of February. And here in the command that we ran, event time end was set to the 3rd of February, but dbt didn't include this date and didn't generate the batch for that date. So that means if you need to reprocess only one batch in the past, for example, then you have to specify the respective period for event time start. And for the event time end, you have to specify the next period. A bit uncomfortable, but maybe dbt will change this in the future. So since, so remember that the microbatch incremental models are now still in beta. And yeah, that was it for the demo. I will stop sharing my screen for a moment to switch back to our presentation. Okay, just a small recap. In this session, we walked through the new microbatch incremental strategy in DBT, starting with its purpose and key benefits. We explored how it simplifies processing large time series datasets by breaking them into manageable time-based batches, automating parallel execution, and minimizing the need for complex SQL logic. Also, we covered how microbatches work, their configurations, and how they compare to other incremental strategies. And during the demo session, we saw microbatches in action, how we can configure and run microbatch models. I also would like to mention that Scale3 has a variety of trainings available. Some of them might be relevant for your project. For instance, we have one related to DBT and Data Vault 2.0. In this training, you will learn DBT even if you don't have any experience with this tool. And also Data Vault for DBT, which is one of the main areas of our expertise here at Scale3. So I think this training might be the best combination for those who would like to learn the Data Vault 2.0 methodology together with the tool for its implementation. Additionally, we have other trainings, the one related to Data Vault 2.0 automation with Veriscape, for those who are interested in working with Veriscape, for example, which is one of the alternatives to DBT. And finally, the one related to the agile data warehousing, and the example of how it's applied to the development of Data Vault-powered enterprise data warehouse. The training is relevant for those who would like to apply agile development in their data warehouse projects to bring them on a new level. So go to scale3.com and check those trainings if you are interested. Yeah, so also go to scale3.com/dbttalk and register for our next webinars. If you would like to have a DBT session, DBT Talk Hub and Speak session on some particular topic or functionality, you can send your questions up front by filling out a form, which can also be found there. So thanks for your attention and see you in our next sessions. Bye.